Okay, so what we're going to do here is we're going to continue talking about the structure of an atom. And specifically what we're going to do is we're going to dwell more on the electrons themselves. Now, in the last lecture, what we did is we talked about how electrons fill how electrons fill the electron shells, and how the outermost shell is called the valence shell, and those electrons are valence electrons. And those electrons basically dictate how the atom is going to interact with other atoms. So before we go on to actual bonding, we're going to talk about something called ions. So now let's take a look at sodium for a second. So if we look at sodium, sodium has got an atomic number of 11. Okay? So ions. So sodium, atomic number is 11, which means that there are 11 protons. This also means that there are 11 electrons. 11 electrons. Now, if we draw this out, so we're going to put 11p in our center. So if we draw this out, so we got 2 electrons in our first shell. Then I got to put 1, 2, 3, 4, 5, 6, 7, 8, giving us a full second shell, but I still need to add one more electron. So I have to add a third shell, and I have 1 electron right here. Okay, so now this is our valence. Okay, and this is the valence electron. Okay. Now, if you look at this, we can see that the third shell is empty. The third shell is empty. And what this does is this adds a little bit of instability to this atom. Okay, it's very reactive. So what tends to happen? What tends to happen with shells that have and with shells that are unfull is, one, they'll either gain electrons to fill the shell, or they'll get rid of electrons to empty the shell. So the valence shell is full. In the case of sodium, we have 1 valence electron sitting here, and what sodium tends to do is it tends to lose this electron. So what that does, if I lose this electron, I've got 11 protons in the center. So 1, 2, and then I'm going to have 8 on this outside. And what that's going to mean is I have 11 positive charges on the inside, and I only have 10 negative charges on the outside. So that means the net charge of this atom now becomes +1. That is the net charge. And what that does to sodium here is it gives it a positive charge. And what that makes the sodium then is an ion. And an ion is simply a charged atom. Okay, it's got a charge on it. Now, there are 2 flavors to the charge. If it is positively charged, it is called a cation. It's positively charged. And it is called an anion if it is negatively charged. Okay. One of the questions that I'm typically asked by students is, why can't you just add or remove a proton, to balance out, charges in such a way? And the reason is if you add or remove a proton, you're changing the element. We can only mess with electrons when we want to mess with charges on atoms. So if I want to make an atom more negative, I have to add more electrons to it. If I want to make an atom more positive, I have to take electrons off of it. I cannot change the protons. And I'll put that as a note right here. You can't mess with the protons. Okay, you can't mess with the protons, okay? Because if you do, you change the element. So looking at sodium, this is how we make sodium a cation. So now let's take a look at one of the most common atoms to become an anion, and that would be chloride. So that's Cl's got an atomic number of 17. So let's take a look. So Cl is atomic number equals 17, which means that we have 17 protons, which means that we have 17 electrons. So let's draw this out. So we got 17p, which means that we have to have 17 electrons floating around. So we got 1, 2 in the first shell. We're going to have 8 in the second shell. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so now we got a total of 10, so we have to add 7 more electrons. So we got to add our third shell. So 1, 2, 3, 4, 5, 6. Here's our 7th one. So you see right here, we have space for another electron. So we pretty much have an unfilled valence. We have an unfilled valence. We have a reactive atom and kind of an unstable atom. So we have two options here. One, we could get rid of all of the electrons on that outer shell, or we could take the simpler approach and we could just add one electron right here. And the general rule that I give students, and it's not incredibly scientifically based, but if there are three or less electrons on the outer shell, three electrons or less, they're just going to get rid of the electrons. Okay, and if there are like six or seven electrons on the outermost shell, they're just going to add electrons. Now, there's a big wishy-washy space between, and there's a huge variance. And in a beginning biology class, you're never going to deal with more than like 2 or 3 electrons on a shell, or 7 or 8 electrons on the shell. So it's really not. There's really not much of a judgment call that you have to make. Okay, so it's going to be very obvious. But usually if you have a mostly filled valence, if the valence is mostly filled, it's going to be easier to add electrons onto the valence than it will be to kick them off. And if you have a mostly empty valence, it's going to be easier to kick the electrons off than fill up the rest of the valence, which is what we see in Cl here. Okay, since we have a mostly filled valence shell with 7 electrons, it is easier to bring an electron on to fill the valence than to kick the rest of them out. So now the important thing to realize is, now what is this going to do to the overall charge of the chloride? Okay, so the Cl. And so what this is going to do is, now on the inside of this nucleus we have a plus 17 charge. Now we have a negative 18 sitting on the outside. So the overall charge of Cl now is negative. And that's how we make an anion. It's like I said earlier, if we want to make an atom more negative, we have to add electrons. Okay. In the case of sodium, we made sodium positive. The reason sodium becomes positive is because it loses its electron, and therefore becomes more positive. Okay, and that's all an ion is. It is just a charged atom. A cation is a positively charged atom. An anion is a negatively charged atom. Okay, so now bonding. So now we're going to talk about chemical bonding. And there are really two chemical bonds between atoms that you have to know about. The first is a covalent bond. And what a covalent bond is, it is a sharing of valence electrons. And the second is an ionic bond. And what it is this is an attraction of opposing charged atoms. All right. Yeah. So we're going to talk about the covalent bond first, and we're going to use the easiest one. We're going to use hydrogen. So covalence. Hydrogen has one proton, which means that it's got one electron floating around. So this is an unfilled valence. This is an unfilled valence. And what it really wants to do, what this valence really wants to do, is it wants to get another electron in it to stabilize out the valence shells. Now there's several options, but what hydrogen typically tends to do is it tends to share this electron with another atom. And for this, in this case, we're going to use another hydrogen. So this is hydrogen. And so another hydrogen also is around. Okay. It also has one electron in its valence. So if you get these two hydrogens that are really reactive, you know, as atoms individually, what we find that happens is they tend to share their valence. So what happens is we get hydrogen and they start to move close enough to where the valences between them combine. The valence shells of them combine, and what they do is they share the electrons. They share the electrons, and they have a combined valence. And that is the definition of a covalent bond, is where we have the sharing of electrons by combining the valences. Now, how do you determine how many electrons that they can share? Well, you just have to look at the valence. So the maximum number of electrons on the first shell is 2. So only 2 electrons can be shared in the first shell. So let's say I have carbon. Okay, let's use carbon for an example. So carbon has an atomic number of 6. You can see right there. It's got an atomic number of 6. So this means if we have carbon, it's got 6 protons. So it's got 1, 2 in the first shell, and then it's going to have 4 in the second shell. Now, how many electrons does it need to fill this valence? And so the answer is 4. It's got a blank spot here. It's going to have a blank spot here, and a blank spot here, spot here. Okay, so it can share 4 electrons. Okay, so this means that carbon can bond to 4 things because it can share 4 things. Oxygen has an atomic number of 8. So if you look here, oxygen's got an atomic number of 8. So O. Oxygen, it's got 8 protons. So if you fill this out, it's got 1, 2. Second shell, it's got 1, 2, 3, 4, 5, 6. So how many can it share? It can share an electron here and one there. So it can make 2 bonds. 2 bonds. Okay. One of the most common covalent bonds that we're going to see is hydrogen and oxygen making water. So if you look at this, so if I look at this right here, so if I drew oxygen, let's do oxygen again, 8 protons. Two, 3, 4, 5, 6. And then if I have hydrogen, it's got 1 proton out here. And I have hydrogen with 1 proton out here. And if these come together, what's actually going to happen is the valence shells here are going to be shared. Well, let me do that in another color to make it more discernible. The valence shells are actually going to be shared. Here, the valence shells are going to be shared. So what we do is we get sharing of these electrons. So this electron and this electron will be shared. This electron and this electron will be shared. So now, because we share electrons, if we count the valence electrons, 1, 2, 3, 4, 5, 6, 7, 8 of oxygen, they're now shared. They're now shared. Now, if we count the valence electrons on hydrogen, 1, 2, 1, 2. Hydrogen's valence is filled, and that's how we get covalent bonds. Covalent bonds. Now, how you write this out? Is you can use the lines. So oxygen will bind with hydrogen. And that is H2O. And what these little lines mean right here, that means 2 electrons. That is 2 electrons. So that shows us how many electrons are shared between them. Now, if we look at oxygen binding to oxygen, like O2 gas, oxygen binds to oxygen. What this is this is called a double bond. So I'm sharing 2 electrons here. I'm sharing 2 electrons here for a total of 4. 4 electrons are being shared between them, making a double bond. So now if I had something like a triple bond, so let's say carbon, triple bond. Okay, so carbon can have a total number of 4 bonds. You see 1, 2, 3, 4, like we showed here. So now each one of these lines, bond, 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 that's 2 electrons, 2 electrons, 2 electrons. Okay, so this is called a triple bond. So, and it can have here's 2 electrons, and here's 2 electrons. So I am now, carbon is totally maxed out. So carbon can have 4 total bonds because it can share 4 electrons. Okay, and then the most other common one is nitrogen. Nitrogen can have 3 bonds. So nitrogen gas is N2. N2 is triple bonded as well. So nitrogen can have 3 bonds. Right. So this is so these are covalent bonds. Covalent bonds. Now there are a special type of covalent bonds. That are called polar covalent bonds. Polar covalent bonds. Now, in the case of water is the actual important one. So if you look at oxygen really likes electrons. So now if we look at this right here, so we know that there are 2 electrons here, and there are 2 electrons here that are being shared between the oxygen and hydrogen. So 2 electrons are being shared between oxygen and hydrogen on this side and on the other side. However, oxygen's kind of greedy oxygen is really greedy for electrons. And what tends to happen is the electrons like to hang around the oxygen more than they like to hang around the hydrogen. Okay, the valences are still filled, but the electrons prefer to be around oxygen. And what this does is if all of the electrons are around the oxygen, what that's going to do is it's going to give oxygen a slightly negative charge. Okay? And if all the electrons are around oxygen, what that's going to do is it's going to give the hydrogens a slightly positive charge. And this little funky thing is called D, delta D. Delta minus and delta positive means slight, very small. Okay, and that's what's called a polar covalent bond. Okay, the electrons are being shared between the oxygen and the hydrogen, but they're being shared unequally. Okay, so let's just say that electrons, they buzz around the atoms, and let's say in an ideal situation, an electron would buzz around oxygen 5 times and then buzz around hydrogen 5 times. So they'd be equally shared. But in this case, it's more like the electron buzzes around the oxygen 9 times and then it goes and buzzes around the hydrogen 1 time. So it spends most of its time around the oxygen itself. Okay, and that's what makes a polar covalent bond. Okay, so what this means is that water, this is the shape of the water molecule. Half of the water molecule has a negative charge. Okay, or the oxygen part of the molecule. Sorry, the oxygen part of water has a negative charge, and the hydrogen part of the water molecule has a positive charge. Okay, that's covalent. That is a covalent bond. Okay, all right. So that's all we got for covalent bonds. Now we're going to look at ionic bonds. Ionic bonds. Ionic bonds, remember, are charge, attraction due to a charge. Okay. Due to a charge. So this is between cations and anions. Okay, because you know that opposites attract. Positive is attracted to negative. Positives don't attract each other. They repel each other. Negatives repel each other. But a positive charge will attract a negative charge. So what we're going to do is we're going to look at sodium chloride, what you know as table salt. So sodium, we know that sodium has 11 protons. So let's draw it in here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then it's going to have this one lone electron up here. And then this is the valence electron, the outermost electron. Okay. Now we know, and then we're going to see Cl. And that's got 17 protons. So we're going to draw that in. 1, 2. We're going to have a full second shell. 3, 4, 5, 6, 7, 8. And we're going to have a mostly full third shell. 4, 5, 6, 7. Okay. Now we already talked about before the formation of cations, and we talked about the formation of anions. Okay. What sodium is going to want to do is it's going to want to get rid of the electron to stabilize out its valences. And Cl, what it's going to want to do is it's going to want to add an electron in order to fill out its valence. This is very convenient. It is very convenient for both sodium and chloride that this happens. So what's going to happen is the Cl is actually going to steal. It's actually going to steal this electron and it's going to put it right there. So now what's going to happen is now we're going to have Cl, and it's going to be negative. Sodium, it's going to be positive. And then what have we just done? We have made a positive, we have made a negative, and these two are going to attract each other making sodium chloride. Sodium chloride. And that is how an ionic bond works. And it works for all cations and anions. This is how it works. So all you need to do is calculate out where the electrons are, and you can actually figure it out. So that's sodium chloride. And the reason we use sodium chloride is because it's the most common one. Okay. Now let's just do, for example, let's go back up to the top, look at our periodic table. Let's do potassium chloride. So potassium has got 19. Okay, potassium chloride. So potassium is a metal, just like sodium is. So potassium, so K, it's got 19 protons. So we're going to fill these in. So here's our first shell. 1, 2. Got our second shell. 3, 4, 5, 6. Okay, now we've got to put in another shell. We're dealing with a fourth shell on this one. Okay, so that's full. That's 18. So now we got to put on a fourth shell. Right there. Okay, that's potassium. Again, we got one little electron on our valence that's going to want to get rid of. And then we have our chlorine. It's got 17 protons. Chlorine, sorry, it's chlorine. 1, 2, 3, 4, 5, 6, 7, 8. And then we got to put 7 more on. 2, 5, 6, 7. Okay. Same principle here. Cl is going to want to add 1 here, and potassium is going to want to give that up. So chlorine is going to steal this, and it's going to put it right there, and it's going to make our Cl negative. It's going to make our potassium positive, and what we're going to get is KCl, potassium chloride. Okay, that's an ionic bond. Okay, now let's do one that's a little bit more complex. Even in its complexity, it's really simple. We're going to look at magnesium. Magnesium, Mg. It's got an atomic number of 12. Okay, so Mg. Okay, let me lower this a little bit. Magnesium. It's got 12 protons. So let's fill it up. 1, 2. Second shell. We can put 8, giving us a total of 10. Now we've got our third shell. 1, and we're going to put 2 right there. Okay. All right. So now we've got a little conundrum. Okay. So you're like, well, there's 2 electrons on there. Okay, and before you start to flip out and be like, oh my god, what do I do with 2 electrons? I'm going to say, so what? Okay, is it mostly full or is it mostly empty? And the answer is that it's mostly empty. So what did we say before? If it is mostly empty, you're more likely to get rid of electrons. Okay, so we're going to use magnesium chloride. So we're going to do 1 chloride, Cl. Okay. And remember, Cl's got 17 protons, so we're just going to fill this up. Second valence. And then we got our third valence. 7. Okay. So we got an empty spot here, and we have an electron that it will steal. This electron will go here. It'll go right there. Okay. Now, if you look at this, we've still got 1 electron around magnesium. Okay. So right now, magnesium is positively charged. Okay. We've missed 1 electron. It's still got 1 electron it can give up. So what this means is it's got to give up another. It's got to give up another electron to another chlorine. So we have to have Cl 17p. So we have to have another one. And so we've got a free space sitting right here. And what we're going to do is we're going to take that one. It will be ripped off. So now we have Cl, it's got a negative charge. We got Cl, it's got a negative charge. Now we have Mg, it's got a 2 positive charge once we get rid of those 2 electrons. And then what's going to happen is this magnesium will be attracted to both of those chlorides. So we got MgCl subscript 2. That magnesium will bind 2 of them. So that's the complex. That's the complicated ionic bonds. And again, it's really not that complicated because it literally follows the rules. It follows the rules. Which brings us to our next thing. We're going to talk about notation for a second, chemical notation. Okay, so how we notate things chemically. Let's just do water, for example, H2O. Okay, so now we use the symbol for the element or the atom to represent what it is. Okay, not symbol. The symbol to represent what we're dealing with. We use subscripts behind. This is a subscript. Subscripts behind to give us the number of atoms we're dealing with. So here, this subscript means that I am dealing with 2 hydrogens. So that is 2 hydrogens. Okay, and there's no subscript here. Plus 1 oxygen. Okay, 1 oxygen. Okay. Now, if I were to put a number in front of this, so if I were to put 2H2O, this number in front of my formula, means that I have 2 water molecules. Okay. That means I have 2 times 2 hydrogens, so that's 4 hydrogens, and 2 times 1 oxygen. That means I have 2 oxygens. Okay. So other times you will see things in parentheses. Sometimes you will see things in like PO4. You'll see things like this in parentheses, like this, with subscripts behind it. That means I have doubled whatever is in the parentheses. I've doubled what's in the parentheses. Most of the time you won't see that for what we're doing, but occasionally you will see it if you go further and further on. So that just means I've got two phosphoruses, and then I've got 2 times 4 oxygens, so I've got 8 oxygens in that. Okay, so that's all the parentheticals mean. Okay, and so the last thing that we're going to talk about is what is the difference between a molecule and a compound. So a molecule are bound by covalent bonds. Okay, they're bound by covalent bonds. Right? So H2O. So basically that's water. Okay. CH4. Okay, that is carbon with 4 hydrogens on it. Okay. Those are covalent bonds. Okay. A compound, I'm just going to do that. Molecule compound is one or more atoms combined. One or more atoms of different types. That's what I want to. One or more atoms of different types combined in a fixed ratio. So what this means is it doesn't matter if it's an ionic bond, it doesn't matter if it is a covalent bond. Okay, but it has to be one or more atoms of different types. So NaCl, sodium chloride, this is indeed a compound. Okay, H2O, it is a compound. Okay, because there's a fixed ratio, 2 hydrogens for every 1 oxygen. For sodium chloride, there's 1 sodium for every 1 chlorine atom. So, and even though it doesn't matter if it's an ionic bond or not, okay. However, O2. We're going to put a big old red X to that. That is not a compound. And the reason is because O2 is 2 oxygen molecules. Okay, so you can't have the same molecules bound to each other. Okay, there have to be 2 or more different types in a compound itself. So now the question that I get most often from students is, how can you tell if a bond is ionic or if a bond is covalent? Okay, and so the easy way I'm going to tell you, and it will work for basic anatomy and physiology, is we're going to go all the way back to the periodic table. I'm going to go back to the periodic table here. Okay, so I'm going to erase these arrows here. Okay, and I'm going to select the red. Okay, if you are dealing, and I'm gonna make it a little bit bigger. If you are dealing with these, if you were dealing with these guys, if you see these in the chemical equation, and I will even narrow it down some more. If you see that, you see sodium, you see potassium, you see calcium, and you see magnesium. So if you see lithium, sodium, potassium, magnesium, and calcium, if you see those 4, lithium, sodium, well, let me take the arrow out. Take that out. Lithium, sodium, magnesium, potassium, calcium. Okay, if you see those in the equation, like lithium chloride, calcium carbonate, any of those kind of things, if you see, let me just go back up, that was stupid to do that. If you see these, lithium, sodium, magnesium, potassium, and calcium in the chemical formula, you are dealing with an ionic bond. Not always, and this is just a shortcut cheater's guide to it, but if you see those, it's ionic. It is an ionic bond. Okay. All right. I think that should do it. Yeah, this has become very long. So that will do it. We'll talk a little bit more about ionic bonds in the next one, because there's a couple more properties about ionic bonds, especially when we're dealing with water. But we're going to deal with water. We're going to be dealing with water, and we're going to be dealing with acids and bases in future videos. So that's all I have for this one. And again, I'm sorry it was so long, but there was a lot to get done. Have a great rest of the day.